Hi all. Today we'll be discussing the LeetCode problem of the day. Find smallest letter greater than target. So here you're given an array of characters which is sorted in non-decreasing order, and you're also given a character target. So you just have to return the smallest character in this letters that is lexicographically greater than the target. And if not such character exists, then you just have to return the first letter, the array. So if you look at examples, here we have letters C, F, and J, and your target is A. So among these letters, C is the smallest character, which is greater than A. F and J are also greater than A, but you have to return the smallest character, which is greater than A. So output for the first case will be C. Now for the second input, your target is C. So again, a smallest character, which is greater than target. So it can't be equal to target. It should be greater than target. So because of that, your answer will be F. And finally, for example 3, your target is Z. But in the given letters, there is no character which is greater than Z. So you will output the first character of the array, which is X. Now coming to the constraints, the length of the array will be up to 10 per 4, and it contains only lowercase English letters from A to Z. And it is guaranteed that letters will be sorted in non-decreasing order, and letters will contain at least 2 different characters. And also target is a lowercase English letter, again from small a to small z. Now let's go the approach. So suppose you have this array and your target is G. So simple approach would be to just start iterating from left to right and check if your current character is greater than G, then that's value written. So first you'll check A is less than G, so you'll keep moving forward. So C is less than G, E is less than G, F also is less than G. Then when you are at H, you'll see that H is your target is greater than the character. So you can simply return your answer, return the H. And suppose in case where your target is Z. So in this case, even if you iterate on all the characters, you won't find any character which is greater than Z. So in your loop, if you don't find the answer at the end, you can just return the first character. So this is a basic approach where your complexity will be order of n, because you have to iterate on the entire array to find your character which is greater than your target. So we can do better than order of n. So again, let's say target is G. So in the question, we can see that the letters array is sorted in non-decreasing order. So since we have it in a sorted order, we can do a binary search. So for that, we'll just take boundaries left here, right here, and we'll find the mid. So suppose, let's say your mid is here. So you'll just compare what is the character, mid character with the target. So here we can see the mid character E is less than G. So that means in the entire left part of this mid, you won't find the answer because the array is sorted in non-decreasing order. So since E is only not greater than G, all the elements to the left of E will also be not greater than G. So we don't need to search this place. We can just update our search space to be the right part of the array, which is from mid plus 1 till R. And suppose you're at here, and this is your mid. So now you will again compare your mid character with the target. So here we can see that O is greater than G. So that means, according to the question, we have found a character which is greater than G. So in your answer, you will set O because O is greater than G. But since you want to find the smallest character in letters that is greater than the target, so after setting the answer, if you move to the right, you will keep finding the bigger characters. And since you want to find the smallest character, you will set right equal to mid minus 1. That means you will reduce your search space till here. So two simple things. If your current character is less than or equal to your target, that means the first case, you won't find the answer in the left part. So you will set left equal to mid plus 1. And else, so else means your current character is greater than target. So you have found a character which is greater than target. So first you'll set answer equal to array of mid. And since you are interested in finding a smallest character, you will reduce your search space. You will reduce your right r equal to mid minus 1. So when we do this, in the next iterations, maybe mid can land here. And in this case, h is also greater than g. So you will update your answer from O to h. So in this example, I think h is only your answer. And again, we need to handle the edge case where if you don't find the answer, like we discussed, if your target is z, then you just have to return the first character. So for that, instead of initializing answer as some garbage value, we can always initialize answer with the first character, and we can perform the binary search as discussed. If you find the answer in the array, well and good. And if you don't find the answer in the array, so the first character by default will be returned. Now let's quickly code the approach. So first let me take character answer equal to letters of 0. So this is the edge case where you won't find the answer. You won't find any character which is greater than the target. So now for running the binary search, let's take left equal to 0 and right equal to letters dot length minus 1 and run a while loop to simulate the binary search. So while left is less than equal to right. So first we'll compute the mid and you will check. So if my letters of mid is less than equal to target, that means I did not find a character which is greater than target, so I need to move to the right side in order to find a bigger characters since the array is non-decreasing. So you'll just set your L equal to mid plus 1. And in the else case, so else denotes that letters of mid is greater than target. So since you find a character which is greater than target, we'll first set it in answer letters of mid, and then in order to find a smaller answer, you will reduce your right equal to mid minus 1, and that's it. So at the end, you will just return your answer. I think this is M. Okay, let me submit. Yeah, and it works. Finally, let's do the time and space complexity analysis. Now, coming to the time complexity, since we are performing binary search, and at each iteration, your search space gets reduced by half. So the total iterations are order of log n, where n is the size of the letters array. And coming to the space complexity, we are not creating any additional array. We are just initializing few variables. So your space complexity will be constant, which is order of 1. I also have the code in Python. If anyone wants to view it, I'll add this in the description as well. And let's catch up in the next video.